Hello everyone and welcome to another video. In this video we are going to do these 4 questions which are based on mirror formula. So mirror formula gives a relation between the focal length, the object distance that is u and the image distance v. So it's 1 over f is equal to 1 over v plus 1 over u. Magnification of spherical mirror, it is the ratio of the size of the image to the size of the object. An object 4 cm high is placed at a distance of 20 cm from a concave mirror which produces a real image 5 cm high. And what we have to find out is the position of the image, and the second is what is the focal length of the mirror. So we are given the object height, and how much is the height of the object given as 4 cm. We generally use h for indicating the height of the object. Symbolically it is represented with h letter. So we can say height is 4 cm. Further, we are given the distance of the object from the mirror, and you should know that by convention object is always placed to the left of the mirror, and anything which is measured to the left of the mirror from the pole is taken as negative. So we are going to take h as, not h, the object distance which is indicated by u, and u instead of 20 will be writing negative 20 centimeter. Now we have one more information, that is the image formed is real and its height is 4 centimeter. So when the image is formed real, it has to be inverted, right? Real image is always inverted and it is always to the left of the mirror, same side of the object. So now we can say that we know the height of the image. And how much is the height of the image? 5 centimeter. So as I said, it should be taken negative. So instead of 5, we'll be taking negative 5. Now in the first go, what we have to find out is the position of the image. And position of the image is indicated by letter V. For that, we are not going to use this mirror formula. Instead, we are going to use this relation between the height of the object and the image, and this distance of the object and the distance of the object. So let's say if I plug in what we have h dash as how much? H dash is negative 5. So I'll be writing negative 5 over h, and h is 4 centimeters. So that is 4 equals how much is v? Well, v is what we have to get. So I'll be writing negative v as it is, and the distance of the object which is u, that is minus 20. Now check, first I need to cancel this, and then I go to cross multiplication. So it's 4 times v is equal to negative 5 times into 20. So that results to give you v as how much? Negative 5 into 20 divided by 4. This get cancelled by 5 times. So we got v as negative 25 centimeter. Now once we got the size, distance of the image, so this is what we had to calculate in the first part. We got it, centimeter. In the next part, what we have to find out is what is the focal length of the mirror. Well, for that we are going to use this mirror formula to find the focal length. So it's 1 over f equals 1 over u, and how much is u? U is negative 20. So negative minus 1 I'll write above, and 20 over here, plus 1 over v. V is also negative, so we are going to write minus 1 over 25. Next is to take LCM. LCM comes out to be what? 100. 24 times and 4 into minus 1, plus minus is minus 5. 4 times, I did a mistake. This would have been 5, right? Because 25 times is 5 times, and this is 25 4 times. So 1 over f comes out to be negative 9 over 100. So on reciprocating should give you the value of f, which is minus 100 over 9 centimeter. So this is the focal length which we had to calculate. In this question, he says an object which is 5 centimeter in length is placed at a distance of 20 centimeter. So we know the size of the object. We also know the distance of the object from the mirror. Further, It's mentioned that it is a convex mirror whose radius of curvature is given. So the mirror is convex and the radius of curvature is 30 centimeter. What we have to find out is the position of the image, its nature and size. So position of the image is the first thing, nature and size. These are the things that we have to find out. Now let's begin with the first thing. We know the height of the object. The length of the object is same as this height. So this is how much given as 5 centimeter. And the distance of the object from the mirror, as we know that the object is always placed in the left hand side of the mirror, irrespective whether it's a concave or convex. So by convention, anything which is placed to the left of the mirror is taken as negative. So we are going to write as negative 20 centimeter. The other information that we have is the radius of curvature, but keep in mind it is convex mirror. As you can see in the figure, in a convex mirror the radius of curvature, this length, right, it is to the right, it is measured to the right of the mirror. That's why we are going to take this as positive. So let's write down the radius of curvature, and the radius of curvature is positive 30 centimeter. Right. Now we know that we have to find the position. Position is what? Position is the V here, and the size is H dash. So we are going to use mirror formula in this case to find the values. For using this mirror formula, as we can see that we need F. So we are going to use another relation, that is, we know that radius of focal length is half the radius of curvature. This is what the relation we have. So you can see that this is the focal length and this is the radius of curvature. So it is half. So we can find out the focal length from here. That's very clear that focal length is half the radius of curvature. Radius of curvature is 30, so focal length is going to be 15 centimeter. Now let's plug in the values in the mirror formula. This is what the mirror formula. This is 1 over F, and how much is F? F is 15, is equal to 1 over U, and how much is U? Where is U? This is U. So this is negative 20. So I'll be writing minus above and 20 below, plus 1 over V. Now in order to get, I'll transpose this number to the left hand side. So it's 1 over 15 plus 1 over 20 equals 1 over V. Next is to take LCM, and the LCM is how much? 60. 15 4 times and 15 4 times, right, and 23 times is equal to 1 over V. So now we can say from here, that's from this is what, 7 over 60 is equal to 1 over V. So V is going to be how much? 60 over 7 centimeter. And you can see that V is what? V is positive here. So anything distance, any distance which is positive is what? To the right of the mirror. So now we can say that the image so formed here is to the right hand side, right? And they are here, which we can say behind the mirror, and that's why we should say that the nature of the image is virtual and erect. Now further, we also have to find out the size of the image. Size of the image is H dash is what we are going to take. So we are going to use this relation, that is magnification relation. So H dash being the size of the image, H being 5 centimeter here, is equal to negative V, and V is this, right? V is this. We have calculated V over here. So V is 60 over 7, that divided by U, so U is how much? We have U as this. So dividing is same as multiplying with the reciprocal. So I'm writing this as 1 over 20. So this is H dash over 5 equals, I can reduce this by 3 times. So it should come as what? Positive 3. Why? Because there is 2 negative sign multiplied. Positive 3 over 7. So finally we have H dash as how much? 15 over 7. So that will give you h dash 15 divided by 2. It should be 2 point how much? So 15 divided by 7, sorry, should be 2.14. So size of the image is 2.14 centimeter. So you can see that these were the two things that we have to find out. That is, number one, size of the image, which is 2.14 centimeter, and second is the V, and V is how much we got? 60 over 7 centimeter. Now third thing was the nature. As I said, the image is behind the mirror, so it should be virtual and erect. In this question, it says an object of size 7 centimeter is placed at a distance of 27 centimeter of a concave mirror of focal length 18 centimeter. So what information we have? Number one, size of the object, distance of the object from the mirror. Other things that we should remember, that it's a concave mirror, right, and whose focal length is 18 centimeter. So let's write down the information we have about this. So first thing that we have is the size of the object, which is how much? 7 centimeter. So this is 7 centimeter, and the object, which is, as I say, which is convention, that object is always kept to the left hand side of the mirror. Anything which is measured to the left of the pole is taken as negative by convention. So this is negative 27 centimeter. Next, you see that it is a concave mirror, and you can see from the figure that concave mirror, the focal length of the concave mirror is to the left, right? It is measured to the left, so you can say that this again will be negative. So it's going to be negative 18 centimeter, that is focal length, minus 18 centimeter. Now, what other things that we have to find out? Number one, I can see that at what distance from the mirror should the screen be placed, right? So what you know, that in a screen only real image is formed on a screen, right? Only real image can be obtained on a screen. So finding the screen distance, finding the distance of the screen is same as finding the image distance. One more time, finding the distance of the screen from the mirror is same as finding the distance of the image. That means we need to calculate V here. Other things that we have to get is to find the size and the nature. So size of the image is what? H dash. Nature, whether it's a virtual, well, we have already get to know that it is formed on a screen, and the image which is formed on the screen has to be real. So let's obtain what other things that we have to get, that is H dash. Now we are going to use this mirror formula in order to find V first. So I'll be replacing F with how much? 18. So it's minus 1 over 18 equals how much is U, and object is always placed on the left hand side of the mirror. So I should have written this as minus. So this is minus 1 over 27 plus 1 over V. Transposing 1 over 27 to the right hand side, so it becomes 1 over positive 27 minus 1 over 18 is equal to 1 over V. And what's the LCM here? 54 should be 27 2 times and 18 3 times is equal to 1 over V. So I should write it here, right? I'm doing it here. So this comes out to be minus 1 over 54 is equal to 1 over V. So by cross multiplication, V comes out to be negative 54 centimeter. So we can say that the distance of the image from the mirror is 54 centimeter, which is same as the distance of the screen. So once we have obtained V, and I should write it here, V we got as how much? This is negative 54 centimeter. Then we are going to obtain height, and we are going to use this relation, that is H dash is what we have to get over H, and H is how much? 7 centimeter is equal to negative V. Well, V is here. This minus sign is for the formula, and how much is V? V is negative 54. That divided by U, and how much is U? U is negative 27. So now it is h dash over 7 equals this minus into minus, that is plus 54 over minus 27. So this can be reduced by 2 times. So h dash comes out to be 7 into 2, that is 14, and there is one minus, so that is negative 14 centimeter. So we got the size of the image, or maybe height of the object, as negative 14 centimeter. So these were the two things that we have to find out. Number one, the distance of the screen, which is same as the distance of the image, and second is the height, and third is the nature. And nature we have already discussed that it is real and inverted. So it's you should write in the exam, this is real, right? Real image is formed, and real is always inverted. Right. In the next question, it says a 10 mm long object is placed vertically in front of a concave mirror. So the first information that we have is the length of the object, or the size of the object is given, and it is a concave mirror. Further, it says that a 5 centimeter long image of the object is formed at a distance of 30 centimeter in front of the mirror. So this is what the image of the mirror, length of the image is given, and it is formed at a distance of 30. So the image distance is given as 30 centimeter, and where it is formed? In front of the mirror. Well, this is important, that it is formed in the front of the mirror. So you should remember that when the image is formed in front of the mirror, it has to be real and inverted, right? It should be real and inverted, because that will be formed on a screen. Anything which is formed behind is virtual and erect. So, and finally what we have to find out is the focal length. So let's write down the informations that we have. Symbolically we are going to represent it. So first information is the length of the object, and length of the object is same as the size of the object, which is, we'll be using the symbol h to indicate it. So h is how much? 10 mm, and it is placed at we have the we know the size of the image as well, and the size of the image is what? H dash. So we'll be writing h dash, and as of now I'm writing, you see the image formed is what? You can see it is real and inverted, so I should write this as negative, right? This is important again to understand that we have to use the sign convention, and according to sign convention, if the image formed is real, it has to be inverted, and inverted, which is anything measured perpendicular and below, should be taken as negative. That's why I wrote this as minus 5 mm. Now continuing with other information, it says the image is formed at a distance of 30 centimeters. So we have understood that it is on the left hand side of the mirror, so it should be taken as negative. So we'll be writing f as what? Oh, sorry, the image distance, right? The image distance is v, and v is going to be how much? Negative 30. So negative 30 mm should be its image distance, and we have to find out the focal length. So you see that for finding the focal length we need u and v. We have v, but we don't have u here, and that is the reason first we are going to use this relation, that is h dash over h is equal to negative v over u. So h dash over h, and how much is h? H and h dash both is known to us. So this is h dash is minus 5 and h is positive 10 is equal to negative of v. So we have v as negative 30. So there is 2 minus sign over u. Now this will be, it can be reduced by 2 times. So it's minus 1 over 2 is equal to, these 2 minus will interact to give you positive 30 over u. So by cross multiplication we are getting u as minus 60 centimeter. Now student can have some confusion that one thing even I wrote, this was centimeter, not millimeter. So student have confusion that should we bring them in the same unit? Well, you should remember that these two h and h dash should be of same unit, and u and v should be in the same unit. It is not necessary One more time, these two may be of same, has to be in same unit, and these two has to be in same unit, but not H and V. They necessarily not be of same unit. These two necessarily not be of same unit. But then, since our V is in centimeter, U should also be centimeter. Now once we got the object distance, now we can use this formula, that is the mirror formula for finding the focal length. So this is 1 over F is equal to 1 over U, and U is how much? Negative 60. So I'll be writing minus here and 60 here, plus 1 over V, and V is how much? This is V. So I'll be writing minus above 1 over 30. So plus minus is minus, so you can write one negative sign in between just. Right. So this is 1 over F is equal to, LCM is going to be 60. This is minus 1 times, and this will be minus 2. So 1 over F comes out to be minus 3 over 60. Yes, it can be reduced by 20 times. So we got F as how much? Minus 20 centimeter. So focal length is what we had to find out. Yeah, this much only, the focal length which we have to get, and we got the focal length as how much? Minus 20 centimeter. And the negative sign confirms that it is a concave mirror, because in case of a concave mirror, F is negative. This distance is negative to the left of the mirror.